from the review. Number 11 says, graph, state the domain and range. I'm going to add in the words asymptotes, and I'm going to do all the other extra pieces that I'm going to ask you for doing. Okay? Now remember when I went through this, asymptotes are, there's either a vertical one or a horizontal one. There is not a slant asymptote for any of these today or for tomorrow. Slant asymptote you'll see when you get to college. So, first one, the vertical asymptote is where you'd set the bottom equal to 0 and solve for x. So x minus 3 equals 0, or x equals 3. That's the vertical asymptote. Everybody okay with that? Okay, now, the horizontal asymptote. This is where I gave you the 3 different scenarios. I said if the top was bigger than the bottom, there was none. If I said the bottom, or if the top was smaller than the bottom, it's y equals 0. And if they're the same, then you put the lead coefficient divided by the lead coefficient. With this particular problem, where's the x on the top? There isn't one. So that's like saying x to the 0 power. What's the x on the bottom? X to the first power. Who has more? 0 or 1? The bottom. When the bottom is bigger than the top, it's y equals 0. If they are the same, then we put the lead coefficient divided by the lead coefficient, which we'll get to on one of the other problems. Okay? That's the asymptotes. Also, that controls the domain and range, doesn't it? So if I not draw a straight line, apparently. I'm going to label my asymptotes in here first. 1, 2, 3, make a line that goes this way. Y equals 0 is the x-axis. Now, as far as the curve goes, how can you get the shape of the graph for you? Use your calculator. Can you put it in your calculator to see what it looks like? Absolutely. What does it look like? Does it come this way? And then take the turn up? And then something like that? Is that about where it goes? Or not? Or does it do something different? What do you mean the opposite way? So it should come this way? Should go down? Since none of you were asking or telling me at the beginning, I just see if you guys were paying attention. Good job. So, for that particular concept, you have the asymptotes. What's the domain? X cannot equal 3. What's the range? Y cannot equal 0. And then you sketch the graph. Can you handle that?
Yeah.
Awesome. Okay, number 12. Okay, let's find the asymptotes. Vertical asymptote. Remember, what do I do first? Set the bottom equal to 0. X plus 5 equals 0. X equals negative 5. Okay, for this particular thing, the horizontal asymptote does change a little bit. Why? Because of the plus 2. What does a plus 2 do on the outside? Moves everything up. Okay? Or down, depending if it's positive or negative. But with a plus 2, it moves it up. So what's my horizontal asymptote if everything gets moved up? 2. 2. Y equals 2. Because, again, everything got shifted up 2 units. So whenever you have this out here, that's going to shift the whole thing up or down. That's something that we have had, I don't know how many times this year. Adding on the outside will shift everything up or down. Okay? So if I go up 2, there's my asymptotes. Will the graph look the same as what Savannah described to me in the last one? What I mean by that is, does it turn the same way? The only difference is I just moved it over, right? Okay. What about the domain and the range? X cannot equal -5 in the range? If you had -infinity to -5 and then -5 to infinity, that's also the same, yes. Okay, if you wrote it in interval notation, that's the way you'd have to write that. And basically what that's saying, and here's what a lot of people screw up on that one, Zach, is they only do one side of it. But realistically what I'm saying with the first one is, when I say -infinity to -5, I'm saying this part of it. And when I say -5 to infinity, I'm saying the right side of it. So you got to have both pieces. And the same with the range. You go -infinity to 2, 2 to infinity. Never ever a bracket, always a parenthesis. Okay? What do you think so far? Okay, now what? What do I get? How do you find the horizontal asymptote when it's in this type of situation? 3 divided by 1, which is 3. It is the same as what we just got done doing. The only difference is the format. When it's got x plus or minus a number on the top like that, that's just been combined. The last one that we did where it had plus 2, if you got a common denominator and added them, you'd have something that looks similar to this. Okay? So when it's in this type of format where you have more than one thing on the top, that's where you set the lead coefficient of the front or the top divided by lead coefficient of the bottom. So I have the grids in there. 1, 2, 3, 4. 1, 2, 3. And does it have the same motion as what Savannah had for her first one? When wouldn't it? If we have a negative in there, we'd flip it over. Okay. What's the domain? Range? And there again, -infinity to 4, 4 to infinity for the domain, or -infinity to 3, 3 to infinity for the range. Are you guys comfortable with graphing? Again, I'm going to ask you for the asymptotes, the domain and range, and the graph itself. Did you answer that? Yes, you did. So that's the first page. That's 1 through 3 on your test, just like this. Are you guys okay with it? Then, 18. '18 has this, and this is where I helped a lot of people on Friday with this type of problem, or this one in particular, because of the fact that they were trying to do more with this than what it's asking you to do. What is the problem asking you to do? Add. Right, find the sum or difference. And in this particular problem, we're just adding. Some of you were taking it too far. You were trying to figure out what x is. Is there an equal sign in this problem at all? No. If there's not an equal sign, then all you are doing is adding or subtracting. Okay? So, to finding a common denominator, here's where some of you really, really struggled. Looking at the number 6. If I look at the number 6 and I look at the number 2, I can't go down, but I can go up. Multiples of 6 are 6, 12, 18, 24, and so on. Multiples of 2 are 2, 4, 6, 8, and so on. What's the smallest number that they both share in common? Good. So I need to have it down here as a 6. Now, looking at the x's, I have an x plus 3. So I'm going to write that group. And then when I have this one, is x the same as x plus 3? No. That'd be like the same as you saying 1 was equal to 4. Not happening. So I need an x there too. Have I accounted for all the pieces now? Yes. I took care of every piece. So 6, x plus 3, and a single x. When you're doing this now, you look at it and you ask yourself, self, from this one to this one, what changed? The x. So I need an x involved. What's 5 times x? This one's a little bit more complicated. It was 2x. Now it's 6 times x plus 3 times x. What do I need? What am I missing? I need an x plus 3, and I need to times it all by 3. Kylie, where'd you get the 3 from? I had to take 2 times 3 to get the 6. Most of you were forgetting that on Friday when I was helping some of you. Now, the other thing that we could do, notice where I put the 3? Does it matter where I put the 3? No. But the reason why I put it there is because I like to do my FOIL first. What's x times x? What's x times 3? What's 4 times x? And what's 4 times 3? And if I combine like terms, that's what I have. But remember now, everything needs to be multiplied by 3. What's 3 times x squared? What's 7 times 3? And what's 12 times 3? Now combine like terms. Is there any other squareds besides the 1? What's 21 plus 5? What's 36 plus no friends? Now, a quick question for you guys. Could I rewrite the x in a different location on the bottom? Did some of you guys write it as 6x and then times x plus 3? Did some of you write the bottom as 6x squared plus 18x? So some of you might have multiplied that out. It's your choice. You don't have to, though. Is there any other thing that I can do with that problem? No. So that's my answer. Number 19. And that's what I'm giving you. Now, one of the things I hope you guys realize this. When we gave you problems like this, typically speaking, the one that needs to factor and the one that doesn't need to factor. So like on the x plus 8, that can't factor, but the x squared plus all that other garbage can. Typically speaking, we didn't give you so that they had different terms. When I factor the one on the right, I bet you x plus 8 is going to be there. Only because we wanted to try to keep it simple for you. So, when you're adding and subtracting, again, no equal sign. All I do to find the common denominator, the first thing that I do is I try to factor it to see what I have. Some of you are just multiplying them by each other, which isn't wrong, but it's going to get you in a world of trouble. You're going to have a lot more stuff and pieces, extra that you don't need. So what times what gives me x squared? What times what gives me negative 24, but adds up to be 5? Positive 8 and negative 3. And this is what I was getting at. Do you notice how this is the same as this? The x plus 8s? That's not by coincidence. Okay? Now, when I come up with my common denominator, the first thing that I will do is I will write down the first group, x plus 8. And then I'll jump over to the next part and I'll write down pieces that are new. Do I need to write another x plus 8? No. But I do need to write x minus 3. Now, have I gone through all the denominators? Yeah. Do I have any pieces that I don't have up there yet? Or am I good? You're good. So then x plus 8, x minus 3. So when you're going through this now, looking at the first one, it was an x plus 8. Now it's x plus 8 times x minus 3. What changed? X minus 3. Which means I distribute that into here. What's 5x times x? What's 5x times negative 3? Good. Looking at the second fraction, do I need to multiply it by anything? No. Because this bottom is the same as this bottom. So therefore, can I just keep it the same? Yeah. Now what? Yeah, combine like terms. What's 5x squared plus no friends? What's negative 15 plus 4? Minus 9. All over x plus 8 times x minus 3. What would be the difference if I had a minus there instead of an adding? I'd just subtract the like terms instead of adding the like terms, right? But would the process be any different? No. The next one. X plus 2. X squared plus 4x plus 3. Minus 5x over x squared minus 9. Now, a number of people I was helping with this one yesterday, or on Friday, where we weren't factoring all the way. Some people were factoring the first ones, then not the second one, and I don't know why. Some people were just multiplying one versus the other. I saw one person cross multiply on this one. Why is cross multiply not an option? It's not an equal sign. It's just a minus. So first thing I want you to do, maybe the first step, I don't know, maybe on your quarter sheet you might want to write this down for these. First step is get a common denominator, or for the most part, factor the bottoms if applicable. So what does the bottom factor into? What times what gives me x squared? What times what gives me 3 but adds up to be 4? Huh? 3 and 1. Now what times what gives me x squared, but then when I multiply the back groups gives me negative 9? X minus 3 and x plus 3. Some of you were thinking on Friday that that didn't factor. But when it's an x squared minus a number like that, especially when it's a perfect square number, it's going to be like x plus 3, x minus 3. Do you notice that one of the groups is the same? Okay. So now when I go to write this out, again, so step 2, write the common denominator. So when I do that, I'm going to write down every one from the first group. What is the first group? X plus 3 and x plus 1. Does it matter the order? No. Then when I jump over to the next one, I'm only writing pieces that I have not already written. I've already written an x plus 3, so I don't need to write it twice. What's the new part, though? Good. Have you accounted for all the pieces? Yes. So that's step 2, is come up with the common denominator. Step 3 would be identify what the new part is and multiply it into the top. So for the first one, what's different? Good. And in that particular context, you need to FOIL. What's x times x? What's x times negative 3? What's 2 times x? What's 2 times negative 3? Okay, now, something else that I've also noticed over the last week or so has been your foiling skills. Some of you have been putting for that one, you've been telling me it's x squared minus 6. They have not foiled correctly. You did the F and the L, not the OI. Okay? So make sure that you actually be methodical with it. Take your time. Get it right. I'd rather you get it right. So on the back group, what's different? And then multiply it in there. What's 5x times x? What's 5x times 1? Now I'm going to combine all my like terms now. Again, but this time we got a minus instead of an adding. What's 1x squared minus 5x squared? Negative 4x squared. What's negative 3x plus 2x minus 5x? Negative 6x. Minus 6 had no friends. Again, do I want you necessarily to multiply out the bottom? No. You can leave it in factored form. If you did, it wouldn't be wrong, but just don't waste your time doing that. What do you think about number 20? You have 4 of these to do on your assignment or on your test tomorrow. My guess, without looking at it in front of me, if it's 4 of those and that was adding and subtracting, it's probably 2 of each. Now, the other thing about this problem, before we go any further, is the top can factor. And in some cases, you might want to factor it in order to see if anything cancels, because after all, it is a fraction. So what I'm going to do is if I take out a negative 2, that gives me 2x squared plus 3x plus 3. But can it go any further from here? What times what that's going to give me 2? What times what that's going to give me 3? We'll work together to make 3. It isn't going to happen. So I will take either one of the answers that are up on the screen right now. However, if it did factor and something canceled, then you need to do that. But in this case, nothing canceled. Zach, was that what you were going to ask? Okay. But that's number 20. Are you guys okay with adding and subtracting?
Yep.
Then what numbers do we go to? 25?
5, 26, 27.
Okay. So on 25, 26, and 27, look at the directions. Solve the equation. Check your solutions. Very similar to the ones I told you for 8, 9, and 10. Weird. Okay, this problem, just how it is. You have 2 options for solving. One of them is to cross multiply because of the fact that it is one fraction equaling another fraction. Or option 2, you can multiply everything by the common denominator to get rid of all the fractions. Either way, it's the same thing. So which way would you like to attack this one? Cross multiply? Again, the only way cross multiplying works is if that's one fraction equaling another fraction. As soon as you have 3 fractions involved, like one side has a plus or a minus, nope, not going to be cross multiplying anymore. So, if I cross multiply, what's x times 7? And when I multiply to the bottom, what do I get? I'm glad you said 10 and not 2. Again, that needs to be distributed. If you don't distribute the 5, you're going to get it wrong. So at this point now, there's no more fractions. You just got to solve for x, which means there's no squared either. So get all the x's to one side, all the numbers to the other. So if I subtract 5x to the left, I get 2x equals 10. Divide by 2, and x equals 5. Now, is 5 a good answer? If you put 5 in here, is it going to make 0 on the bottoms? 5. That's not 0, so we're good. How about 5 plus 2? Is that 0? No. The only answers that would not have been good is if I would have got 0 or if I would have got negative 2. Because 0 going in the front would have made it 0, or negative 2 going in the last one would have made it 0. So I'm good with the number 5. We're done with the problem. Yay, team. Okay. 26. Can you cross multiply this one also? Yeah. Why? It's one fraction equaling another. Do you want to do it that way? Yeah? Okay. So when I cross multiply, does it matter which way you go first? No. What's x squared minus 4 times 4?
4x squared minus 16.
Good. What's 8 times x minus 1 times x plus 2? What do you got to do?
You have to distribute the twos.
Okay, if I distribute the 8, that's saying 8 times x minus 8 times by x plus 2.
So you get 8x squared minus 8x plus 16x minus 16.
Okay? And what Tamara did without telling us is she FOILed it. Did she FOIL it correctly? I think so. So, now what? Because I have squared left over, that means I'm going to move everything to one side versus the other. What side would you like to move everything to? To the right. Do you know why you're going to the right this time?
Because
There's more on the right. That's one option. Also, for me, it gives me my squared as positive. What's 8 minus 4? What's negative 8 plus 16? What's negative 16 plus 16? Goes bye-bye. Now we had one like this in our problem set, and some of you were wondering what I do with this, and how do I factor this, and all that kind of stuff. Remember, the first rule of factoring should always be, can you take anything out to begin with? Do they share anything in common? What? And so if I take a 4x out, what do I have left? Two. Because 8 divided by 4 is 2. Now, what do I do with each group? Set them each equal to 0. 4x equals 0. If I divide by 4, what's 0 divided by 4? 0. And x plus 2 equals 0. If I subtract 2 to both sides, I get x equals negative 2. Is that an issue? Or are both of them good? The 2 isn't. Why? If I put negative 2 back in this one right there, negative 2 squared is 4. 4 minus 4 is not going to happen for this. Remember, you can't divide by 0. So this just goes away, and all I'm left with is x equals 0. Okay? Then on 27. Can you cross multiply for this? No. Why not? It's too much stuff, right? So, first thing I like to do is any whole number, I'll put it over 1. Then I like to factor all the bottoms, just like I did for combining like terms, right? For adding and subtracting, factor. X plus 4, nothing factors. 1, nope. How about 2x plus 4? I said, yeah, 2x plus 8, but you knew what I meant. Okay, if I take a 2 out, that's what I get. Now, why did I do that? So I don't have overkill. Now, this particular one is where we're going to use the ginormous set of parentheses. Ginormous. And I come up with a common denominator, just like I did for adding and subtracting. But this time I'm going to multiply it put it on the outside, and then multiply it in. So when I work with the first one, x plus 4 gets on the outside. Do I need to write a 1? No, but you can if you want, right? Some of you have to, and that's okay. Then when I jump ship over to this one, do I have everything? I'm missing a 2. Do I now have everything accounted for? Yes. So then when I shoot it in the front, I have x plus 4 times 2 times 2x plus 7 all over x plus 4. The x plus 4's go bye-bye. That is correct. Then if I multiply whatever's left over, what's 2 times 2? 4. And then what's 4 times x plus 7? Plus 28. 4 times 7, 28. Then, when I shoot it in the middle, I have x plus 4 times 2 times 2. Negative 2, actually. Did everybody see where I got the negative 2 from? Because of the minus sign. That is correct. But do you know that that is the biggest culprit why people get it wrong? They don't multiply that right. So be very careful. What's negative 2 times 2? That's really short.
But no step.
Okay. Negative 4 times x plus 4 is? Now, in my experience, what happens to most of you, when you FOIL this out, you get the negative 4x squared, but you say plus 16, and that's wrong. That's why the negative is important. Make sure you put it there so that way you don't forget that both of them are negative rather than positive. Okay? Now, how about when I shoot it in the back? I have x plus 4 times 2 times 2x plus 20 over 2 times x plus 4. All that goes gonzo. And what do you have left? 2x plus 20. Now, before I start moving everything from one side to the other, I'm just going to clean up the left side a little bit. What's 4x minus 4x? Okay, now, they're on the same side. Do not add 4 to the other 4. If they're on the same side, it's whatever sign's in front. Okay? A lot of people have tried to add this over to here, but they're on the same side. So it's 4 minus 4, which is nothing. What's 28 minus 16? 12. Equals 2x plus 20. Solve for x. What do? Subtract 20. What's 12 minus 20? Negative 8 equals 2x. Divide by 2. X equals negative 4. Great job. Does it work? Why not? Negative 4 plus 4 on the bottom is 0. Or 2 times negative 4 is negative 8 times, or plus 8 is also 0. Not going to happen. What if it's the only answer? No solution if you don't have anything that works. Again, you're going to have 3 of those. And the last type that you're going to have is just like number, what did we give you, 12? You start a small beekeeping business. Good for you. Your initial costs are $500 for equipment and bees. You estimate it will cost you $1.25 per pound to collect, clean, bottle, and label the honey. How many pounds of honey must you produce before your average cost is $1.79? This is exactly like what I'm going to give you tomorrow. So, initial setup fee, bless you, is $500. Plus, how much does it cost per jar? $1.25. What letter would you like to use? B for bees, J for jar, H for honey? Whatevs. Doesn't matter. I'll say B because I heard B first. Divided by B. Now, here's why. If I were to set up something for you guys, let's say it's like a math tutor session, where it was an initial setup fee of $500 plus $1.25 every time you go. How much would it be to make it worth $1.75 or $1.79 to you guys? Is what you do is you take the initial $500 plus the amount of hours you guys put in times $1.25 divided by how many of you there are. We spread it out over the course of the entire group. 179. Now, how do I solve that? Yep. Yeah, bye. Hey, how do I solve? You can cross multiply. We can put that over 1 and we can cross multiply that all day. So I get 1.79b equals 500 plus 1.25b. How do I solve for b? If I subtract $1.25 out of $1.79, what do I get? .54. And how do I solve for b? Divide by 0.54 to both sides, and how many whatevers do I need to get? $925 point what? So if I round that to the nearest, because I'm not going to go 925.92 pounds, because I'm probably selling it by the pound jars. What would I round it to? 926 pounds. That's it. Very similar to your test. Now again, what I would suggest that you do when you make your quarter sheet or your note card, use this as an option for you. If you're comfortable with it, you can turn it in, but if you're not, use this to help you study. Practice the problems. If you think just having your notes is going to save you, it's not unless you practice. That's how you get good at things. Practice. That's why I'm such an expert pancake maker. Okay?